In the last lesson, we talked about two methods of solving simultaneous equations. One is the elimination method and the other is the substitution method. In this lesson, we will learn how to solve simultaneous equations using the substitution method. This will be the method that is suitable for all scenarios and it will be the one that is more commonly used. To solve simultaneous equations using the substitution method, you can follow these 5 steps, which is to first label the equations 1 and 2, then select a linear equation and make one unknown the subject and label it as equation 3. Next, substitute equation 3 into the other equation that has not been used. Find the unknown and finally substitute the value found in step 4 into equation 3 to find the other unknown. I am not trying to tell you to memorize these 5 steps. Once you practice many times, these 5 steps will be in your mind. So let's try some questions using this 5-step method. Let's try this question together. Let's use the 5-step method to solve the simultaneous equation. In the first step, label the equations 1 and 2. So these are the two equations given. Let's label them. Next, select a linear equation and make one the unknown. Since both are linear equations, we can use equation 1 or 2. I'll choose equation 1. Then I'll make y the subject. It doesn't matter whether you make y or x the subject. For this question, since you have 1y but 5x, it is easier to make y the subject. Once you have made y the subject, label this equation as 3. Now we have used equation 1 to make equation 3. So equation 2 has not been used yet. Hence, equation 2 is the equation that has not been used. We will substitute equation 3 into equation 2, the unused equation. Next, expand the algebraic expression and solve the equation to find x. Once you have found x, substitute it into equation 3 to find y. In this question, you should get x equals 1 and y equals 2. Before I go through this question, you may like to pause the video and try it first. Alright, to try this to solve the simultaneous equations, we'll use the 5-step method. So firstly, let's start by labeling equations 1 and 2. Next, select a linear equation and make one unknown the subject and label this equation as equation 3. So if you look at equation 2, there is 1y, and this is easier to make y the subject. So therefore, I chose equation 2 and made y the subject and label it equation 3. Next, substitute equation 3 into the other equation that has not been used. So I've used equation 2 to make equation 3. 1 has not been used, so I'll substitute equation 3 into equation 1. To find the unknown, I'll expand the algebraic expression and solve for the unknown x. So once x is found, I'll substitute x into equation 3 to find y. So for this question, you have x equals to half and y equals to 2. Next, let's solve this simultaneous equation. Unlike the other two questions that you have tried previously, this is not an entirely linear simultaneous equation. Reason is because you will see a square for y here. So once you have an unknown with a power or an unknown multiplied by another unknown or an unknown divided by another unknown, then it will be a non-linear equation. Alright? Okay, but for this second equation here, this is still linear because both x and y are to the power of 1 and they are not multiplied by other unknowns. So to solve this simultaneous equations, we still use the 5-step method. So firstly, let's label equation 1 and 2. Alright, so once you have labeled equation 1 and 2, next let's select a equation and make one unknown the subject. So in this case, equation 1 is a non-linear equation, but equation 2 is the linear equation because x and y are both to the power of 1. So we will choose equation 2 to make one of the unknown the subject. So in this case, we will make x the subject because it is easier because you only have one x but two y. Okay, so once you have made x the subject, label it as equation 3. And we have used equation 2 to make equation 3. So equation 1 has yet been used. So we will substitute equation 3 into equation 1. All right. Once you have done this, expand the algebraic expression and solve for y. Since you have y squared, so y to the power of 2, you will have two solutions for y. So in this case, you get y equals to minus 10 and y equals to 2. So if there are two values for y, there would be two values for x as well. So we will sub both the y values into equation 3 to find the corresponding x values. All right. So in this case, you'll have two sets of answers. So you'll notice that when x is 25, y is minus 10, and when x is 1, y is 2. So things to take note if you are dealing with a non-linear equation. Okay, you use the linear equation to make one unknown the subject. This is because if you are to use the non-linear equation to make it the subject, it is going to be harder. Okay, you'll be dealing with plus and minus and so on. So to simplify things, always use the linear equation. Okay, so for step 2, always use the linear equation to make one of the unknown the subject. Second thing to take note of, if you have power 2. All right, so if you have y squared or you have x squared and so on, if the power is 2, then you'll have two solutions. Okay, so in this case, you have two values of x and y because you have y squared. All right, let's try another simultaneous equations that has a non-linear equation. All right, so in this question, I want you to solve the simultaneous equations. You can pause the video and try it. All right, so how is it? So similarly, we'll follow the same 5-step method with the first step being labeling the equations 1 and 2. Next, select the linear equation and make one unknown the subject, okay, and label the equation 3. So equation 1 has square and you also have unknowns being multiplied with each other. So equation 1 is a non-linear equation, but equation 2 is a linear equation. Both x and y have power of 1 and you do not have unknowns multiplied with each other. So we will select equation 2 to make one of the unknown the subject. So in this case, I'll make x the subject. So now once I've made x the subject, I'll label this equation as equation 3 and substitute it into equation 1, which has not been used yet. Okay, extend the algebraic expression and solve for y. So in this case, I have y equals to negative 1/3 and y equals to negative 1. So once I have found the values of one of the unknown, in this case y, I will sub y equals to minus 1/3 and y equals to minus 1 into equation 3 to find x. Okay, so now I'll get a pair of values of x and y. How was it? Okay, next let's try another question. Solve this pair of simultaneous equations. The steps are exactly the same. So we'll use the 5-step method and we'll label the equations 1 and 2 first. Next, we'll select the linear equation and make one unknown the subject. So in this case, you have x and y divided by each other in equation 1. So equation 1 is a non-linear equation. Don't use it to make the unknown the subject. We'll use equation 2, which is a linear equation. So once we are done with, once we have chosen equation 2, make x the subject. You can also make y the subject, but in this case, I find that it's easier to use x. Don't worry, you'll get the same answer. So now, once you have made x the subject of the formula and labeled that equation, equation 3, substitute equation 3 into equation 1, which we have not used yet. Okay, so for this question, you will need to do some algebraic manipulation because you are dealing with fractions, algebraic fractions. Into a common denominator, then do a cross multiplication. Okay, then you will be able to solve for the unknown y. Once you have solved for y, next substitute the values of y into equation 3 to find x. And after that, you will find the values of x and y. So similarly, because we are dealing with non-linear equations, and if you notice, the highest power for x and y here, or in terms of y here, is a square. So that is why you have two values of x and y. So you notice that the way to solve a simultaneous equations is quite standard. You always label the equations, then make one unknown the subject. Next, you substitute this into the unused equation and find one unknown before you can find the other unknown. Okay, so simultaneous equations usually do not come out as a direct question like solve the simultaneous equations in A levels. Rather, it is usually part of a question where you end up having two unknowns and you need to solve them, and you need to think of simultaneous equations. All right, we have gone through step by step quite a number of questions. You will see a set of worksheets on simultaneous equations with word solution. Try them so as to reinforce what you have learned. Okay, the method is very similar. Use this 5-step method. Once you have done many of it, these 5 steps should come naturally. So I'll see you in the next lesson.